Battery low.
All right, hey everyone. We're gonna get started on a new project today. The first thing, so I was doing some research on quadratic voting and quadratic funding, just to kind of understand the basics and the concepts and how they work, and potentially you know um, programming a contract to help support that. Again, the contract that we're going to build is it's not production ready. It's just more of a learning exercise to experiment with different functions and different calls and try to uncover the best way and most efficient ways to do certain things. Um, as you can see in the GitHub, I'm not going to complicate this by making an ERC20 token. I just want to kind of get the basics and the mechanics down of the actual Solidity language more than anything else. Um, so there's a good YouTube video that explains quadratic voting and how it works. I put a link here. There's a link in the GitHub. If you go out there, it looks like this, and you can see I copied it, almost verbatim, just to, kind of show the example there. This video, it's 11 minutes long. It's really easy to go through. I'll give the 1 minute version of that. So what it boils down to is just, potentially a more effective way to do voting, and in the crypto world especially, that's going to come into play probably with DAOs. And to me, to sum it up, quadratic voting, it prioritizes getting single votes from a lot of people, than if somebody were to use all of their governance tokens against one particular issue that they were just trying to push through. And so in this example, everyone has 12, voting credits or governance tokens, whatever you want to use. And there are 12 different items up for voting. And so in this case, Joseph A, B, and C, they all have their 12 tokens. A distributes one across all of them. B, is really pushing through the legalization of marijuana, whereas Joseph C is, sort of splitting. They feel strongly about a few issues, and don't really care about the rest. And so in this case, this is their actual, the credits that they're using, but you can see the votes that are actually being cast are simply the square root of how many tokens they used. And so in this case, obviously the square root of one, they're using one token per vote that's getting counted. In the event for Joseph C, for this, they had to, they only actually, got two votes. Um, but they had to spend 4 credits to get that square root of 4 being 2. And so if you look, they're while they only doubled the votes um, of Joseph C only doubled the votes of Joseph A, they actually had to actually utilize 4 times the amount of voting credits to accomplish that goal. And so same here, they used all of their credits on a single issue, um, and but only sort of all 12 became 3.46. And so really, again, what it does, it allows, it puts the power of one vote, and using that versus using all of your capital of all of your tokens to really push through an issue. So it kind of helps to smooth out the curve when you're doing some sort of tokenized system. I probably completely butchered the explanation of that, but just wanted to give a high level. I definitely recommend you going here, watching this video. So we'll go ahead and get this closed. So I've got a fresh repo in GitHub that I've created. You can see it here. Just basic information of what we're trying to do, the steps we're going to take. Definitely giving credit to the YouTube creator in this, if anybody wants to go out and look at it. So I'm really summing this up into a few different steps that I want to focus on. The first, again, it's sort of like a chicken and an egg. If there's nothing to vote on, why do we need voters? Or if there's no voters, why do we need something? So we're going to figure out how to track voters and their balance of voting credits. Then we need to figure out a way, just again, something really high level, how to issue people a bunch of tokens. Then we'll create a proposal. We need to open the voting. We need to close the voting, and then we need to tally the votes to see if that passed or failed. And so this will probably take us a couple videos to get this all built out, but we'll get there. So let me go ahead, copy the repo address, get this back over here. We can close this. Leave. Okay. Let's get a terminal open. Dun, dun, dun. PD dots. Solidity. There we go. And we want to get phone history code. Okay. And let's open it. Code. Okay, so we've got the README, and I know the Brownie inits don't like it, so we'll sort of recycle bin. Yeah, we'll get it back later when we sync. So let's go ahead, get our open again here, and we'll do Brownie init. Oh, wait, oh, there must be some Git files in there. 1 second. There we go. Okay. All right. Before I move on, I've got our original um, task tracker library here. I'm just going to copy over a few environment files to Brownie config just to make our life a little bit easier. Let's pull this environment file over. Let's pull the Brownie config, and then we'll take our deploy function, save us some time, and our helper functions, our helper scripts. Okay. In the config, this looks good. INV, make sure I git ignore has the env files in there. Okay. So I think we're good. Let's just go ahead and kind of start cracking away at the contract. So we'll create a new file. We'll call it quad voting dot. Okay. All right. So first, let's get, I'm just copying from the other one. Let's get our license information set up, our compiler version. I do want to use the Open Zeppelin contracts for this for is ownable, and but I'll pull those in later. And so let's just use the NatSpec documentation style title, and we'll just I won't write out the whole thing here. A contract for issuing voting credits, creating proposals, polling voters, and tallying results. Author is me, Joseph C. Heath. Notice this is not production ready code and is for learning purposes only. Okay, so contract and QuadVoting. All right, there we go. All right, so the first thing we need to do, like we had talked about, and let me go back here. You can copy these in as comments at the top just to help us track our progress. All right. All right, so tracking voters and their credit balances. All right, so let's see. The first, I want to keep track of how many tokens we have out there. And again, I'm going to say tokens. I'm not actually going to issue ERC20 tokens within this contract. I'm just going to create an integer value and an array of token holders, and then a mapping of those addresses to their balances. I'm not going to go through creating ERC20 tokens at this point. Unsigned int. 56. We'll call this, and this will be private. That doesn't really matter. This would be the total credit supply. Let's see, we'll need, this we need an array of addresses of people who are actually voters. And I like to, any of my, like, they're not global variables, but any of my the properties of this contract, I always like to use the underscore. So we'll have an array of addresses for our voters, and then we're going to have a mapping of addresses. Let's see. This is going to be to balances. So you went to 56. And let's see, do we have to mark it as private? I don't think so. We can always, if there's no harm in having people being able to look it up, or would we want to handle that just through getter functions? Let's make it private for now, and we'll call this credit balances. Balances. Okay. I don't right now. We don't need a constructor because these are just all going to default into 0 and empty array, and nothing included in this mapping. So I think we're okay there. Um, so I think we can just write some basic functions to kind of help us keep track of a few things. So the first, let's just say, get balances out of the credit balance table. So I'll create a function, get voter balance. We'll say get voter credit balance, just to get a good name. That's going to accept an address called voter address. This is a public view that returns a uint 56. I think that's right. Oh, here. And this is simply just going to return credit balances for this wallet. Yep. Let's grab the netspec. Let's see, so at notice. It's a returns a balance. It's the balance of voting credits for a specific vote. The parameter is voter address. Address. I think to explain there. And then the return returns here. And you to 56. Okay. All right. And so now that we can get a balance, we need to be able to, I guess, increase the tokens from a specific user. Okay, so let's go ahead, write a function. We'll say add voting credits to voter. This is to address, right? Get add voting credits to address, and that's going to accept an address, say voter address. It also needs to accept the amount of tokens we want to add. That's going to be credit amount. Um, I do want to make this a private function. I don't want it to be able to be called directly. We're going to use another function that will actually call this. So I don't want anybody to be able to access this one directly. And so we need to do two things here. One, we need to add, increase the balance here. Um, what we also need to do is make sure that they are in the we need to make sure that they're in the voters array as well. And if they're in there already, we don't want to add them again. Um, so that the easy part is we want to, um, you know, for the credit balances for this user, we want to, what do they have had? Find out. Credit amount. If not, we would just do a, equals this plus equals the amount. That should be fine. And then if they're, oh, it doesn't like this. Add is not, okay. Add is not found or not visible after argument to look up in unit 56. Okay, so we would just say, plus equals, this should work. Credit amount. That should be available here. If not, we'll make it work. We'll do some. We'll get 2 or 3 of the first functions built. We'll do some tests and then we'll call it a night here. So we've got that. And then, like I said, if they don't exist in the voter array already, we want to add them in there. So we need a way to see if they're already in the list. I have a feel we're gonna in other as I see it when it comes to voting and other things, I think we are going to want to check this quite often, and so I'm going to create another function to do this for us. So I'm going to say function, we'll say is voter. It's going to accept an address, voter address. Let's see. There's no state change, and it can be pub, so this will be a public. It's going to be a view. It's going to return a Boolean, just yes or no. Um, and so we're going to say the easy one is if voters dot is it length or count length length equals 0, then we're just going to say return false because it's not unnamed return variable can remain. Oh no, that's fine. Return false. Otherwise, if they're um, yeah, so if the array is empty, obviously they're not in there already. So is voter equals false. Now the other way to do it is just to say if we need to check the mapping. We check the mapping or like no, we probably need to iterate through the voters looking for them. So let's see, we just need to do. All right, so we need a for loop. So I'm gonna create an address. Yeah, so we're gonna say if I can remember the for loop syntax. So for we're gonna say uint 6I while I is less than voters dot length I plus plus if voters voters I equal voter address, then then return true. And so if we get here, it's going to return. If we go through this for loop, go through the for loop, and we're still okay. Oh, no, one after this. Then we'll return true. And then finally, if we somehow get all the way here, we're going to return false, that they're not in here. Okay, that should clear up all of our warnings. So if here, return false. If somehow it's found in the array already, we're going to return true. If it gets through this and this, then it's going to hit here, and we're going to return false. Okay. Let's scrap this. Ours. Returns a Boolean value based on if the given address is in the voters array. Parameter is the voter address, wallet address, and then returns 45. Yeah, I think right now for these basic functions, these things are always kind of the same. Let's save this, and then we want to check if is voter. Thank you, IntelliSense. For this wallet address equals false. And I like to sort of be specific here versus writing the exclamation point. If is voter is false, then we want to add them to the array. So we would say voters dot push voter address. Okay. Oh, and this is add voting rights address here, private notice. Yeah, it's not a return. Adds adds a specified number of tokens or credits, voting credits to a specified wallet or address. There. All right. And we also need the amount of tokens, amount of credits being added. Okay. Let's just check these. That should be sufficient. I guess let's see if we can compile. All right, good. Alrighty. So let's check our deploy. We got to get these scripts in order. Get account. We're not doing task tracker anymore. We're doing quad voting and quad voting. Let me rename this to make it the same. Go. And here we need quad voting. We need all of these things. We're going to deploy quad voting. No issues there. All right, so that'll deploy it. And then in our helpers, same thing, just our same function as always, just getting accounts. Okay, and if we're on a development blockchain, it'll just get kind of those account zero, those 10 basic accounts that get created with Ganache. If not, um, it goes and it gets it'll go ahead and get the one from our brownie.config, our brownie config. All right, so now we need a test file. So new file. I'm just going to call this brownie test underscore unit test dot py. All right. Um, Let me just grab the header off of my other one. Tests. All right. All right. Need it. What contract? Web3. We don't need Web3 yet. We don't need PyTest yet. I'll just leave them. We'll need them eventually. Okay, so we're going to define a test. Um, so um, we'll check this. All right, so I guess add voting credits to address. All right. So test add voting credits to address. Here, here, here. All right, the first thing we want to do is to contract equals um, deploy contract. We want to say, so we've got our contract, everything's been initialized, and so the first thing we want to do is contract dot add voting to credit addresses. We want to say, let's see, what are we supplying first? Add voting credits, voter address, and then the credit amount, all right? So that's going to be get account. Now get 0, the first account in the list, and then we want to do 2,500. Oh, that's yeah, which is it's thinking Gwei, which we're not working with. So everybody's going to get 100 tokens. How about that? Or credits, right? And so then we want to assert two things. We want to say assert that contract dot oh, get address credit balance. There we go. For get account equals 100. We also want to make sure that assert contract voters, because that should be allowed, right? Voters is, yep. Well, we'll see. Is it? I'll have to check. I don't know if it's public by default or is it private by default. Let me check the other contract real quick. Task tracker. What did I do here for my globals? Da, 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 I did not make them public, so we'll assume that that's fine. We'll just say we know it's in the 0 position. Equals. Just get a count. All right. I think that's it. Let's see, brownie, brown and paste. Okay. Quad voting has no object. Add voting credits. All right, so add voting credits to address. Quad voting. Add voting. Add voting credits to address. Oh, it's a private function. Hello. Because I was gonna do something earlier. For now, I just want to make sure this works. I'm gonna make it public. All right, let's show this again. How do I add voters? Oh, so I guess you do have to explicitly name it public. It's fine. Oh, it's probably on this side. All right, done. Once successfully. Test says add voting credits address to our contract call object is not subscriptable. Contract call object is not subscriptable. Add voting credits to address. All right, add voting credits to address. Address. No. All right, so what? Let's just back this up. Let's do one thing before we even. If those are, we're gonna have some issues with this one. And take that out. Oh, pounds and we'll get rid of this one and this one. Let's just test our um, let's just test our is voter. Assert contract dot is voter, right? Is voter dot is voter. Get count equals false. Oh, false. And I think here. All right, let's just see if we can get this far. And either way, we'll probably wrap it up for tonight and then continue working on it tomorrow. I know whatever that first arrow is. Full object is one voting. Test. Oh, that's true. Equals false. There you go. Oh, and we have to call the function. And we have to call it with get account. Wait. Object has no attribute. Okay. Test attribute error. Boolean object has no attribute is voter. Okay. Well, I'm going to end it here and we'll just pick up tomorrow with working through these areas. All right, take care, everyone.